let's look at transformations of trig functions. We have 4 different variables, a, b, c, and d, and we want to see how they can affect the y equals sine x function. Let's take them one at a time. First up, the a. The a multiplied by the sine function is the amplitude. Here's a graph of a function called y equals 3 sine x. The amplitude is the distance that you go up or the distance that you go down from the central point. In this case, it's the x-axis. Normally, sine x goes up and down to 1 and minus 1, but when you multiply it by 3, it's going to now go up and down to 3 and minus 3. It's a vertical stretch. Now, if a is negative, then that is just an x-axis flip, or rotation if you want to say it. Take it and rotate it over the x-axis. And so the graph of y equals the negative 1 times the sine of x is the red graph. Okay, great. Now let's take a look at b. B affects the period. The normal period of sine is 2 pi, same thing for cosine. The way you get the new period is you divide the old period by the absolute value of b, technically. And so it depends on what b is, whether you are stretching it in the y direction or compressing it. I'm stretching it in the x direction or compressing in the x direction. Here's a graph of y equals the sine of 5x. The absolute value of b is greater than 1. When this happens, it isn't a stretch, it's a compression by a factor of 5. We compress in the x direction by a factor of 5. The new period is going to be the old period divided by b, which is 5 in this case. Basically, in the span of one period of sine x, we're now going to have 5 periods of the sine of 5x. Let me just draw one of them. That's 1. We'll have 2, 3, 4, and 5 of them. Okay. But when the absolute value of b is less than 1, then that causes a stretch. Here's the graph of the function y equals 1/3 of x, or y equals x over 3. And so that causes a stretch in the x direction. By a factor of 3. So here's sine of x, one full period of it, right here at 2 pi. Now we've stretched it out, and for the sine of 1/3 x, we have one full period in the span of 6 pi. We take the 2 pi, we divide it by 1/3, that gives us a new period of 6 pi. So we've stretched it out in the x direction by a factor of 3. This is sine x. So now we should be able to fit 3 full periods of sine x. We're now into one full period of the sine of 1/3 x. So that's how b affects the graph. Well, how about c? C creates a phase shift. That's a shift in the x direction. Okay, but not just by C, by a factor of C over B. For simplicity's sake, I'm going to keep B to be 1 in my examples here. So this is the graph of the sine of x minus pi over 3. So when C over B is less than 0, when it's negative, then that's going to cause a shift in the x direction to the right. This is a shift right, in this case, pi over 3 units. So we were at 0, now we're at pi over 3. We're back here at pi, now we're at 4 pi over 3. And so we've shifted pi over 3 units to the right. When C over B is positive, it'll be a shift to the left. So we'll be shifting left that many units. In this case, pi over 4 units. So sine is here, the blue, and we shift it to the left, pi over 4 units. When we used to be here at pi, now we're here at 3 pi over 4. Okay, a shift left when C over B is positive. And finally we have D, and D will create a vertical shift. Okay, if D is positive, like in this example, D is equal to 4. When D is positive, that's a shift up. In this case, 4 units. And then when D is negative, it's a shift down. Here, in this case, we have sine of x minus 2, so we'll be shifting down. Two units. So here's the shift up 4 units, and then here's the shift down 2 units from the normal y cosine x graph. Okay. Now let's take a look at maybe combining these together. So we have the sine of twice x in number 13. We said that what that does is it gives you that b is equal to 2, and so the new period is the old period divided by b. So the new period is pi. But still, just draw the normal sine graph and have that normal action of going up to 1, down to 0, down to minus 1, and up to 0. Still draw that. But now you have to do that within pi. So now that's going to be pi. You just relabel the units here. And so instead of being 2 pi, now that's a pi. And this is a pi over 2. Here we have a pi over 4. And here we have 3 pi over 4. And that would be the graph of y equals the sine of twice x. Okay. In 15, we have the cosine of pi x. In that case, b is pi. So our new period is 2 pi over pi. So our new period is 2. Still draw the same kind of sine. Oh, no, this is cosine here, sorry. Still draw the same kind of cosine graph. Start up here at 1, go down to 0, go down to -1, come back up to 0, end off at 1. Still draw the normal cosine graph. But now the period is 2. So it needs to be done by the time you get to 2. Half of that is 1. Here we have a half. And here we have 1.5, or 3/2. And that's the graph of y equals the cosine of pi x. Okay. Now let's do some combining. In 17 we have negative the sine of pi over 3x. So the period is going to be 2 pi over 3. That's 2 pi times 3 over pi. It's going to be 6. What does this negative do? It flips the sign over the x-axis. When you want to be up here at 1, now you're down here at -1. When you want to be at -1, now you're at 1. So that's what the sign is flipped. Basically like this. And then we just need this period to be 6. Cut it in half. Cut it in half. And then here we have between 3 and 6. We have 4/2, or call it 9/2. 4.5. 9/2. Okay, and that's the graph of y equals negative the sine of pi over 3x. In 19 we have a shift. In 19 to be the same period, since b is 1. So it's still period 2 pi, but let me draw in cosine first. So here's cosine. And now we want to take that and shift that pi over 2 units. So we have those units there. Now we want to shift where everything is now moved over pi over 2 units. So now we're going to start up here, come through here, come down here, and come back up here. And if we had one more, we'd be over here. And so we take and shift pi over 2 units. To the right. Yes, pi over 2 units to the right. Because it's negative. Okay. And then finally, number 21. And in 21, we have a shift, both in directions, a phase shift and a vertical shift. And so, to help you do the phase shift, it's this before. Now we're going to shift over only on pi over 4 units. And so, this is 2 pi, and this is pi over 2, 3 pi over 2. Now we have these pi over 4 units. And we're shifting up 1 at the same time. So this is like going to be our x-axis shifting up. It helps to draw that in. And it's sine. The period is the same since b is 1. And so it's sine, so it starts at 0. This is the new 0. Let's draw in the sine graph that shifted up 1. Let's at least do that. So we go here, then we go here, then we go here, here, and here. That's y equals the sine of x plus 1. And now we want to shift that pi over 4 units to the right. So it would be here, here, up here, sorry, down here, down here, and up here. Shift pi over 4 units to the right. And this is the graph of the sine of x minus pi over 4 plus the 1.